Great events, Amsterdam, perfect city.
So, unlike my peers, I'm not gonna detail too much about Software AG because we are turning 50 years this year. So if I need to go one year after the other, that might take some time, right? In fact, so I came today from Software AG Den Haag office in The Hague. Traveled from there to Amsterdam. Took me 1 hour and a half instead of the usual 45 minutes. That's the beauty of Netherlands and Belgium. And so I had time to think about all this data that we have around us, right? Around the objects that we're touching or using on a daily basis, right? And I was thinking about this data that we have in our cars, right? Because as you know, our cars are full of sensors. You have tire sensors to measure the pressure of your tires, right? You have temperature sensors, any kind of sensors, right? And I was thinking, this data is not much exploited, right? We saw one of the cases was about, for example, smart insurance, right? So how, as a user, I can have the right, for example, insurance prime based on my driver behavior, right? My driving behavior, right? The way that I pull on the accelerator, the way I drive, the way I use the car. All this data can be very useful to create value, right? From the insurance side, that's one example. The other example is that, for example, last week I had a broken tire, all right? So I had to call the lease company and tell them, okay, what's the usual process? I went to the garage first, and then at the garage, the lease company told me, no, but in fact, you should fill in a form first, right? So I had to fill in a form online, okay, but still, which took me a lot of time, right? And a few hours later, I was finally able to drop the car to a garage to get it repaired. It's still not repaired as of today, but okay. And all those manual steps, right? All those steps that I had to take until my car is serviced. It's important to see how we can automate this data, right? How to automate the extraction of this data and to integrate it with back office system, for example, to create value, right? So in the example of the broken tire, what if this data, right, from the broken tire, I get an alarm, and that alarm triggered an alert in the CRM system of the lease management, and the lease management knew at once all the information about the accident, the car plate, customer, kind of damage, right? And then in turn, send an alarm or automatically schedule a meeting at the nearest garage from home, right? All this automated from end to end, integrated from end to end. Imagine the value, right? So with this kind of example, so this is how we see at Software AG basically every single business, right? You could compare what I've told you as an example for a business, right? How the data can be turned into a value, right? The data from a business can be turned into value. The way we see business today is as data pipelines, right? So if you check, for example, if you see in the manufacturing space, right? If you have an order to cash process, maybe some of you know, I'm going to take a shortcut, but basically you have a customer placing an order, you have an order getting created into your SAP system, and in turn you have an order on the manufacturing plant, maybe in your manufacturing execution system, your MES, right? And then you have the return, all the process chain up to the final caching, right? So when we go to see our customers, usually what we hear is that, okay, let's go for a proof of concept, let's go for an IoT proof of concept, right? I have an idea of a business case, okay, and now I need to choose very quickly the kind of device that I will need, right? So maybe I need a device that is, if I'm working in manufacturing, right, and I want to do a smart manufacturing project, I need to have a device that maybe is resistant to water, right? IP65, IP67. Maybe I need to have a device or a sensor that is resistant to dust, right? All these are purely technical considerations, right? But the problem with that is that you don't see the broader picture, right? It's very important to see the broader picture. Why? Because imagine you start a proof of concept for IoT and you focus completely on the hardware, which is perfectly fine, that's normal, right? That's part of the technical requirements. But if you don't even know what kind of data you need and what you're going to do with the data behind, then your business case is down, right? So it's very important when we approach our customer at Software AG, we try to draw the bigger picture with them. So, going to try the pointer? Cool. So you have connected assets, right? Could be your shop floor, could be a smart city, could be lights, could be anything, right? Various assets, regardless of the kind of asset. And usually at a business, well, you have business applications. You can have SaaS applications, you can have planning system. If you're a shop floor, you have your MES, your historian, this kind of setup, right? So the very first thing that we're looking at, of course, is how we're going to access the data. So this is all the part about how to connect the devices in a kind of agnostic way, right? Make abstraction of the connectivity layer, connect the device, and get the data out of those devices. Potentially, you could also have, and I'm saying potentially, you could have an edge appliance as well. We already explained edge, the benefits, right? So low latency, continuous operation, autonomous operation, right? Being able to run your logic even if the cloud platform is down, right? Or the internet connectivity is down. So this is the data acquisition, let's say, and data connectivity and device connectivity. And by the way, for the edge part, just for the small information, at Software AG, we have one of the biggest IoT ecosystem, right? As well from an hardware, from a connectivity, from a system integrator perspectives, and from an edge perspective, for example, we're working with players like Dell. Right? What do you do with this data? Okay, one thing that you could do, you could say, okay, the temperature of my machine on the shop floor has been for more than 40 degrees over the past 5 minutes, which for me is not acceptable, right? As a KPI might indicate a failure, probably a probable failure. So what I could do is that I could analyze this data in real time, what we call the speed layer, right? And create a visual alert in a dashboard. This is cool, right? Because at least you know that there is something wrong, because otherwise maybe you don't even know that something is going on, right? But this is still reactive, right? Because at the time that you get an alert, it's real time, so the issue is already there, right? And now you need to maybe send a technician on site to repair your machine or to take action. You could also say, I don't need to take immediate action on the data that I'm getting. I could store it for later on, right? I could analyze it over the past month, right? That's more about batch layer, right? And there it could be integration of your data into a data lake, AWS, Azure, you name them, and do some business intelligence behind. So that's one value added that you could have, but you could also say, what if I infuse some intelligence in those objects, in those machines? Right? So instead of getting an alert and I know that something is wrong and I send my technician on site to repair the machine, what if the machine itself was able to predict a failure before it occurs based on the real-time data that is getting in? And that's about basically based on historical data, build some models, right? Whichever language, or Python, using commercial solution like SaaS, doing basically conversion into a PMML standard for those who might know, so predictive model markup language, and deploying those models into the platform itself, right? So that means that instead of being reactive, you become much more proactive. You're doing predictive analytics, right? And then maybe later on used to do preventive analytics. So at this level, you already created much more value, right? But then what? What if, now, let's go back to my shop floor example. I have my trained model that predicts when my machine is going to go down, right? For example, I was going to have a failure. What if I could integrate the data of this data and the data of the machine with my planning system on the shop floor, right? So that I can automate, better predict and better automate the replacement of my machine or the servicing of my machine. And that's the next step. So that's basically the integration part, hybrid integration part. Why hybrid? Because of course, in a business, you would usually have, well, we see more and more, of course, businesses moving to the cloud. This is clear, right? This is not a trend anymore. But you also have to consider legacy systems like your ERP, your planning system, right? So this is about integration, integrating this intelligent data, this analyzed data, with your business application, your business systems. And from there already, you're creating even more value, right? Because you're automating, you're optimizing your plant, your maintenance planning, and so on. Now, what if, on top of that, so it's more about here optimizing the efficiency, optimizing the operations. What if this data, you think that it could be very useful to build services on, or new revenue channels towards your suppliers, towards your customer, towards internal departments of your company. And at this step here, so part also as part of the hybrid integration and API management layer, how to securely expose the data, your business data, your analyzed data, to build services towards your employee, different department, customers and suppliers. So every time we approach customer, we try to talk to them and say, this is perfectly normal that you're looking, of course, at device, hardware, but this is purely technical requirements. Before that, let's try to have together a view on where you want to go and draw the bigger picture together, right? That's how you build your business case also. And of course, all this in a secured and governed way, right? That goes without saying. I think we've talked a lot about security and governance as well. And guess what? To have this complete picture, of course, you could bring building blocks together, and I don't know, take Bosch, which by the way is a partner of Software AG, as we know. So you could take Bosch for the device management part, and then you could take for data analytics, I don't know, a Spotfire, a typical Spotfire, which does not even do the half of all the analytics that I've explained, and then take another integration layer. So you could end up with, five different software, 5 different vendors, right, with building blocks. But then how do you maintain that? It's expensive. How do you maintain that? How do you keep your architecture consistent and your solution consistent? So, by the way, I forgot a key question. Who has already heard about Software AG? Oh, cool, I've got Alex. So very few people, right? Software AG, very short word, pioneer in data integration. We've been existing since 50 years. 50 years is big for a software vendor. It means that we are quite stable, quite reliable. As I said, we have an office in Den Haag, Netherlands, also in Brussels in Belgium. So if you want to meet me there, you're welcome as well. And we are present in more than 70 countries. And as I said, partnership with Bosch. Also know that we are playing with the big industrial players, for example, Siemens. You might know Siemens MindSphere, the IoT platform. Maybe some of you heard about it. Well, in fact, Siemens MindSphere is also itself based on Camilo City platform. So back to those capabilities, right? To get again the full end-to-end picture, you need to have this kind of platform. So as I said, you could have building blocks, but you could also have one platform that does all the capabilities together to the one same platform. So first layer, device connectivity and management. The platform is completely agnostic. So that means regardless of the protocol used, regardless of the network, regardless of the device, we integrate everything, anyhow, anywhere, for any kind of use case. So we integrate Bosch device, we integrate ThinkStream, we integrate purely industrial devices which talk OPC UA, Modbus, Feldbus on your shop floor. We talk different network protocols, different communication layers, sorry. So completely agnostic on that side. And of course, we work with a strong partnership ecosystem to certify devices, right? So we have all our partners. We have a new partnership portal where it's a kind of self-service web page where partners go there, register to certify their device or their sensors, right? And go through all the process until the testing of the certification and the validation of the certification. And because Camilo City is a completely open platform, maybe I didn't mention, it's Cumulocity originally is a spin-off from Nokia, right? So everything which is about device connectivity and security is a strength for Cumulocity. For any device which are not certified with the platform, we provide SDKs, software development kits, to create your own agents to connect your own devices to the platform. Right. So this platform, Cumulocity, is completely open, created into a kind of community spirit. The next layer is data and analytics, right? So how do you extract the real essence of your data? How do you extract only what you need from your data, right? So we saw the two layers, remember? Streaming analytics, speed layer, and batch analytics. Cumulocity is doing both. We have one of the, I think our streaming analytics engine was recognized again this year as the leader. So we are leader in streaming analytics. I didn't mention as well, we are leader also in device connectivity and management on the market. We are leader in industrial IoT, if you saw the latest Gartner Magic Quadrant. So data and analytics, streaming and batch analytics, and also machine learning. Right? Machine learning, if you remember from the previous slide, right? So how to make our machines, our assets intelligent, this is via our AI machine learning capability, right? So the ability to deploy any kind of model, right, that a data scientist could build directly into the platform to be executed or scored against real-time data, right? Next layer is application enablement. So you see some of the applications, smart bike, digital factory. It's cross verticals. It could, so any kind of use case, basically we don't have any focus, even though we have a lot of references in the manufacturing sector with Siemens, also partnership with Bosch, and many others. And we also have third capability, last capability, which is not explicitly mentioned in the previous slide, but solution accelerator. So how to quickly bring value to our customers, right, as a quick ramp up. So basically with prepackaged solution, could be, for example, right now we are developing an accelerator with an Australian partner for smart water management, right? So this is in Australia, where you know that one of the driest countries in the world, and they have big issues with water management, and they're using Cumulocity right now to optimize this water management. That goes without saying, of course, if you need to be able to do the end-to-end picture, you remember from the previous slide with those capabilities, you also need to give flexibility to your customers where they can run the platform, right? So on-premise, on edge, near your assets, in cloud, private, public, and from this side, we are again agnostic. So it could be AWS, it could be Azure, it could be Google Cloud, it could be Alibaba, you name them, right? A few examples, a few value-added examples that we deliver to our customers. And you see the two main flows, right? The two main value streams, so efficiency. This is about efficiency and optimizations. So for Lyreco is one of the biggest facility service company. So basically they are using Cumulocity. They're using Cumulocity for automatic ordering. Right, so that means that when your coffee machine in the office are with empty bins, right, completely empty, there is, or before they get empty, of course, there is an automatic order being sent to the SAP system to basically execute an order and avoid out-of-stock situations. Predictive maintenance, Certus with steam generators. So this is about predictive maintenance, or to predict when your asset might encounter failure. This is based on the last maintenance date of your asset, and also all this data that is analyzed in real time, right? Product availability at Lexmark and product quality at Dürr. So this is a very nice example. I'll jump to it afterwards, which is also using intelligence directly on the connected assets, right, via trained models. But the value is also about creating new services and new models. I touched base a bit about that. So for example, bike as a service in Germany with Winora. So Winora is an e-bike manufacturer, and basically they are using Cumulocity to offer bike as a service, right? So that means what? That means I'm owner of an e-bike. I have an application on my mobile phone. This is Cumulocity running in the background. And I know in real time the geolocalization of my bike. I get alerts if my bike gets out of a geofencing zone, for example, which could indicate that my bike is stolen, for example. So this is kind of service that Winera, is offering together with Camilo City and Deutsche Telekom. Connectivity layer also here is Deutsche Telekom. Insurance telematic, Octo, this is, we're talking about millions of cars connected with OBD dongles, and that sends all the kind of driver behavior information data and integrate it with insurance, for example, systems, right? And this is back to the case where we were saying, how, if I'm a good driver, I never had accidents, why should I pay the same prime that someone who has had more accident or is, for example, more nervous on the accelerator pad and this kind of thing, right? So this is how to provide optimized prime to good drivers, right? Or to drivers with good behavior, proper behavior, right? Smart logistics in the Netherlands, track and trace, so personalized services as well. So this is again more track and trace services for end users. It could also be applied to personal assets like the e-bikes. It's just an example to give you what are the real value, right? The two main value streams that we can get with such a platform that combine all the capabilities into the same platform. Of course, all those customers are in the kind of maturity curve, right? IoT is a journey. I mean, when we're talking about already, we go to our customers and we talk with them and they say, yeah, I would like to start a POC in 1 week, and there is no solid or thoughtful business case behind, then we know that it's not going to fly. So there is, of course, a maturity curve to attain there. First thing is, well, how to get the data, how to access the data. This is the data-driven level, right? So make sense of the data. This is the very basic level. Process-driven, how can I take action? How can I make my data actionable? So trigger a process based on an alarm, trigger a process based on a measurement, for example, right? So getting some intelligence into the data, right? Last stage, that is the example of Duro that we'll see later, this is model-driven. So putting intelligence, infusing intelligence into your connected assets, right? That was the example with the machine on the shop floor on which you deploy a trained machine learning model, and the machine is able by itself to detect whether there is a potential failure based on the data that is sending or receiving, right? So this is self machine learning. And you see here the very important piece, automatically take corrective actions. So that means that you don't need to have a technician 24/24 on site to really look at the machine, right? This is also about saving costs. This is also about optimizing your operations and your efficiency. A few, again, examples along the maturity curve, so the data-driven actions, for example, Gardner Denver, this is about, and by the way, this is Camilo City interface, of course. Fully customizable with, you see, business, technician, any kind of persona dashboard, fully customizable. So Gardner Denver, this was about remote asset condition monitoring. So Gardner Denver produces steam generators for their main customers are hospitals, for example, right? They're using steam generators to sterilize the medical equipment, okay? So the idea of Gardner Denver was to provide a service for their end customers at hospital and so on to alert on failures in real time. So still a bit in a reactive way, but at least they know when there is an issue with one of the steam generator, right? And on the longer term, using historical data and using those real-time data, optimize, again, your maintenance, decrease your maintenance cost, and reduce unplanned downtime. That's one example. Second example, I already touched base about that. This is about Lyrico. This is about making sure that you always have coffee in the morning. Very important, of course. So means, let's say, the level of beans here in your coffee machine is below 10-15%, create an alert automatically from Camilo City and trigger an order fulfillment process into your SAP system, for example, right? So that you don't need to have someone looking around, looking at alarms and saying, okay, I need to order those new beans capsule and so on. This is done all automatically end to end. And that's where the value is added, right? So this is about your supply chain, optimizing it, improving customer experience, no more empty coffee machine in the morning, right? Which makes productive employees, and so on and so on. Reduction of out-of-stock inventories. One of our most elaborated case in the industrial world with Dur. So Dur is a robot paint station manufacturer. They basically sell those robots to all the biggest car manufacturer, BMW, sorry, Audi, even the Ferrari of those worlds. And basically what they did here is that they made those robots intelligent. What does that mean? That means that what they observed, so they collected data for some time, for a few months, and they observed that they were seeing that there were patterns where the quality of the paint on the car was not optimal, right? And of course, where you can imagine when you're in a production chain for a car, you have different activities, right? You have the painting, and then you have maybe putting the doors together and so on. So if the painting activity is not optimal, then the car needs to go back again in the assembly chain. And then, so that means a lot of money, right? Costs a lot of money to do that. And you're breaking the entire production chain, right? So this was about alerting beforehand when the robots had misbehaviors, right? For example, the turning palette of the paint on the car, to the cars, if it was too fast or too slow, right? Or for example, not enough pressure in the paint, so that means there was not enough paint pushed out to the car. All those misbehaviors that could indicate that there's going to be a product quality issue, right? So being able to alert before the big problem arises, right? And this is also, well, of course, a lowered manufacturing cost, improved quality, that goes without saying, but this is also about autonomous operation at the edge. So this is a very nice example of edge analytics and how to make your assets and equipment autonomous and intelligent, right? This is more or less high level what happens. So I think I've already explained it, but this is more from an architectural point of view. So just to explain very quickly. So first, we have some data scientists collecting the data for a few months, right? And based on the analysis of this data, using our tools as well, they build predictive models, right? So how to detect patterns in the way that the robots are behaving, right? The second phase is that real-time data is coming from the robots, right? So the rotation speed of the painting palette and all those KPIs. This real-time data is analyzed by our complex event processing engine, right, in real time. And at the same time, so the machine learning model detects if there are anomalies in the process, right? And those anomalies are directly seen into dashboards, into the Camilo City platform, the very same platform, right? Yeah. So those anomalies are seen. This is kind of basically here the edge appliance, right? So here, for information, it's Dell running BI as an industrial PC, and basically all the edge analytics part is deployed on this AI PC appliance. But we don't stop here, right? Because at the end of the day, again, it's cool to have the alerts real time into dashboards. But how can you automate that? How can you avoid that someone has to always check on his mobile phone or on the platform that there is an alert, right? How can you automate that to say, I get an alert here from the robot telling me that there might be a problem with the robot itself. How can I trigger, for example, a maintenance process automatically so that the technician goes directly, receive a notification and goes directly there? So this is about integrating this data, right? So this data is aggregated and integrated basically with what we call software AG iPaaS. So we also have a platform as a service, low-code apps, complete block-based, right? If you remember the Node-RED, Luvid-RED, this is not the same thing because here we're talking really about an iPaaS. So that means I can connect my SaaS to my on-premise, my SaaS to my SaaS, my on-premise to my on-premise, whatever I want. So this iPaaS basically takes care of integrating this data and creating, in turn, based on the alerts that it receives, a case in the CRM system, right? And all this automatically. So there, you have no manual intervention. Everything automated end-to-end, right? With the value, again, in lowered maintenance cost and lowered, and of course, you avoid this kind of situation where the car needs to go again into the assembly chain because it was not properly painted, right? I guess you all know Forest? No? I should have said that at the beginning because I know when you're the last one to present, I know that everyone, has the drop in attention and so on is difficult, right? It's very difficult. So I thought I should have mentioned that bear with me a few minutes about all the theoretical stuff, and now we can go into the action stuff. Alex, you're the volunteer? Yeah. You're the victim. Now, okay, here's what we're going to do. So this is a bit to explain how we can infuse the intelligence, how we can use machine learning analytics into this platform. This is a very simple case. So what we did is that we built a predictive model with, not with Alex, but actually it was someone else in Software AG in Germany that was, sitting, jumping, and running, and collecting a lot of this data, and we built a predictive model to detect activity of a person, right? Could be that the person is still, is not moving, could be that the person is jumping, could be that the person is running, right? And the idea is basically that we are receiving real-time data. So in that case, I don't have any Raspberry Pi or any fancy stuff. I just have my mobile phone, which is also a connected device. I'm getting data from this, from the sensors installed on the device, of course. Everything which is acceleration, X, Y, Z axis, temperature, barometer. All this data is acquired via a client application installed on the mobile phone. Okay? And based on the acceleration on the X, Y, Z axis that is coming in real time from my phone in the platform, the machine learning model is going to detect whether the person is standing still, is running, or jumping. Of course, I'm going to be honest with you, the accuracy of the model is, I think, 85% when we did the test. So that means you still have 15% of fault tolerance, right? But yeah, I'm sure that Alex does it very well. So. And what we're going to do is that we're going to get this alarm, but remember what we said is that how cool would it be how to create value by automating those alarms into, for example, a case in your CRM system, into your Salesforce system, or into your incident management system. So every time that Alex, that the model is going to detect that Alex changes position or activity, there's going to be a new alarm created, and the alarm is going to generate via this iPass flow a case in Salesforce, for instance. Right? That's what you see here. So I propose that we do it. Sure. So, and that's also an opportunity for you to see the platform in action, right? So, I don't see. All right. Cool. Inflow. This is Camilo City. This is not Inflow platform, by the way. Oh. So this is a custom dashboard that we built for that. I can even say hello to the camera if I want. Cool. But yeah, I mean, it's also, this well, we're a bit laughing here, but that could be very interesting as well when it comes to deep neural networks, for example, image classification or object detection, which is also something we have as part of our analytics capability. You could think of, if again, in the example on the shop floor, you could take a picture of a machine, and based on the analysis of the machine via DNN, deep neural network model, say, okay, I can predict a failure there because, I don't know, there is a wrong position of the machine, or there is something going out of the machine, like smoke or something, this kind of thing. So what I'm going to do is that I'm going to give Alex is going to steal my phone for some time.
Belgian guy's dreamer
to
get a British guy running around.
Right, no, just stand still right now. So what is interesting is that I started, no, you don't need to move. Yeah, you can. So what I did is that I just basically gave the phone to Alex, and I started the application. So you already see that we're getting some measurements. Let me take that. We're getting already the real-time measurement from the phone, right? And those measurements are the acceleration in X, Y, Z axis. Well, of course, if you move the phone, we're going to see this moving, but no. Well, yeah, you can do it. So you see that Alex is moving the phone in real time. So yeah, we'll see the graphs here moving as well. Yeah, I think that it didn't detect the right activity here. But so right now you're still, so if you don't do anything, normally the model will detect that you're standing still actually. So let's see. Right. So you see it changes from run to still. Actually, you are not running, but okay. So run to still. So we are starting from this state, and you see again here that you're a complete flat in terms of acceleration, right? Which is okay. So now you can try jumping if you want. You need to continue a bit. I love to make you suffer. And normally, you don't jump. Oh gosh. No, you're not jumping enough. You need to be you need to be really motivated. Oh, I know why. I know. The client have just okay. Be careful when you cannot shut down the phone. It needs to be open. Yeah. So don't click on it. All right. So run. So see that from still to run, but you're not really running. You're jumping. Okay. Let's see if you can really jump. No, because, so also one thing to understand is that there is still, of course, some latency, because the data is coming every 15 seconds, right? Jump. So that's normal that you see sometimes some latency, because the data is coming every 15 seconds, and the analysis, the prediction of the model is coming at the same time as well, a bit delayed as well. So that might be normal that you're seeing. So now you're still, which is true, right? It's back to still. Now you can try to run if you want, but really run, not... Well, no, this is not running. This is not running, Alex. Still to run. You're running, Alex. I detected that you stole my mobile phone and you run with it. True? True. All right. So this is cool. We have the alarm. But again, remember, how do we automate that? How do we create, for example, a case, say, Alex stole my phone. Okay, I go out in the street. Alex stole my phone. I get an alarm, but I also want to have a case created, for example, right? An incident created. So this is about now the integration of this data. So I'm going to start the workflow, the integration workflow. So the model is more or less accurate. Huh? It's not that bad, huh? Because you didn't really run. I mean, that was really like training style or something. Yeah. I'm not done with you yet, huh? So just stay here. All right. Oh. Okay. Sorry for that. So this is our iPass. So you might tell me, yeah, but this is a different web interface. Yes, it is. But they are both integrated. So this iPass and Cumulocity are fully integrated together with out-of-the-box connectors and so on, so there's nothing to develop. If I open my integration workflow, my workflow integration, sorry, this is very basic and easy to understand. Voila. So you see, simple stuff. I'm listening on all alarms coming from this device, from Cumulocity, and then I have a decision, a branch here telling me, okay, only for the alarms related to the change in activity, then I'm creating a case into a Salesforce, for example, Salesforce SaaS. So I'm going to activate this flow. And for those who know, because I didn't talk a lot about the name of the products, a bit, for example, behind this iPass, for those who might know, this is web methods. Maybe some of you know all the key core component or the core product powering that is web methods, which is our leading integration product. So you see here that the flow already started because we got alarms as well. So you see, blah, blah. So I'm going to switch directly to Salesforce. Of course, you have everything which is about the logging and so on. This is not a product demonstration. This is just to show you. And now I'm going to log into Salesforce to show you the different cases that have been created, right? And how basically we are mapping the information of the alarms into each of the Salesforce cases, right? I should really use a single sign-on, huh? If I could, because this is... Sorry, Alex. Yeah, see, that's good. Google guys. All right. This is not software AG, hein? This is good. This is Gmail. Alors. 1985. Okay. Voilà. So now. If we're looking into the cases that have been created today, I should be able to see a few of them. Lightning, no, I don't want to start now. Come on. I don't like it. Bam. Voilà. So a few cases that you see here. So you see the different evolution, right, with the timestamps from run to still, from still to run, from still to run, from run to still. We could also do it live, so let's do it again live, and for the last time, just to show you that the end-to-end is working as expected. So Alex.
This is great. So this is a connected machine, essentially.
Yeah. Don't touch. Yeah. Well, okay. don't touch anything. All right. Don't breathe. Now run. Yeah, now go ahead. So this I didn't touch anything. I didn't refresh yet. We have 4 cases, right? From 445, and this is now 448, right? So let's do a refresh. And the winner is, oops. Did it change or what? Oh, yeah. So you see 448. I have 2 things. Run to... Well, still to jump, I think that was the first one, because you were still. So you run, but because you don't run correctly, then it thought that you were jumping. And then, from run to still, because you stopped, so the model detected that you were standing still. Right? So this is really a nice integration, or it's of course a simple example, but to show you how we can easily analyze the data from the devices, make sense out of it, and more than that, integrate it with a business back office system, back-end system, and applications, right, to really create the value. Because again, the value is not going to be just to show in your dashboard, yeah, but this is very reactive way. Right now we are more in towards predictive, preventive kind of cases, right? And again, all this into the same platform, Camilo City IoT. If you want to know more about the platform or Software AG, because I didn't really talk about my company actually, even though just that it's 50 years old, so yeah. It's not, in French we like to do this joke, it's software âgé. In French it's âgé, like old. That's the joke we do. But that's not true, don't say that to, to people from Software AG. I think that's pretty much it. Yeah, I think we're good. Thanks, Alex, for the contribution. I really like it.